Okay, everybody, we are doing lesson 9.9 today, and this is solving a nonlinear system by graphing. There's going to be 2 lessons connected with solving nonlinear systems, and today it's over graphing. Tomorrow we'll be solving these algebraically. Now, graphing is a little bit easier because it's all very visual, and we do have graphing calculators, which does make everything like way easier. Okay, so what is a nonlinear system of equations? So as it says here, it's defined, and you'll need to write this down in your notes, a system of equations in which one or more of the equations are not linear. So in a system, it means that you have 2 or more equations. All right, that's the definition of a system, that you have 2 or more equations. All right, so we are going to be dealing just with systems of 2 equations. And it says 1 or more is not linear. So we do know that linear means that we have a straight line, right? No curves. It could be vertical, horizontal, or diagonal. And then one of them cannot be linear. So one of them could be, as it says here, it could be a quadratic, which does make a parabola, or both of them could be a parabola, or one could be a circle, or an ellipse, or a hyperbola. We are going to focus on systems dealing with linear, quadratic, and circles. Okay, that's going to be our focus. So we're going to have these 2 functions, or equations. We are going to graph them, and then we're going to be looking at solving them. And solving is finding the solution set. And the solution set to a system is where the points where the 2 different lines intersect or cross each other. All right? Okay. So remember, intersect means to cross. So for example, we could have a linear equation, which could be a diagonal line like this. We could have a parabola, and the points would be where, for the solution would be where these 2 points intersect each other. So you can see it says here there can be one solution, multiple solutions, or no real solutions. Now what I sketched out down here, this parabola and my linear equation, this would be an example of 2 solutions, all right, because it crosses 2 different times. Now your answers will be written as ordered pairs, all right? So if it crosses twice, like you're gonna write it as like your X and your Y values, there'll be numbers in here, and if it crosses twice, you're going to have like 2 of them. We could cross just 1 time, there could be 1 touching point, and if we have like a situation where we have like no touching, like a linear equation, and then a parabola where they never even intersect. Okay, that is no solution right there. So we would just say no solution as our answer. Okay, so now getting started with solving these systems by graphing. Okay, each of you does need a graphing calculator. You should each have one of those. So starting with number 1, look at our 2 equations that we have here. We have y equals negative x squared plus 7. Now, it's very important that when you're graphing that the equations start with y equals unless it's a circle. All right, we can't type it into our graphing calculator, and we can't really graph it unless it starts with y equals. So the first thing I check is to make sure that both of the equations do start with y equals, and they do. Okay, I'm looking for that. That's good. Then I'm going to go to my graphing calculator, and I'm going to type them in. And you can type both of them in at the same time. So this will be like on your y1, and the second equation, the x plus 5, will be on your y2. So go ahead and go to your y equals and type both of those in at the same time, and then hit graph. Now what you should be seeing as you type these in is that you are going to have, right, a sad parabola, because we have that negative sign in front of our x squared. Anytime x is squared, we have a quadratic, right? Quadratics are parabolas. If there's a negative, it's sad. So we have a sad parabola. And then we have a linear equation, a line that has a positive slope and is moving up, and you can see that they are intersecting 2 different times. So we just need to graph this, and I'm going to add up here, you need to graph, I'm going to say precisely. Don't just like do a random sketch like I just did on the side. Okay, you need to graph precisely. So go to your table of values, second graph. And you're looking at your table, and your y1 column, if you typed them in the order that I had them, should be in the same like order. You should have like an x column. Let me get my table up here. Like we should see this like x, then we have like a y1 and a y2. Okay, those are for your two different lines. The x columns go the same. Now I'm going to look at this and I can see that I'm going to kind of go as far left for my parabola that my x's start with like -4, and we have -9 that goes with it. That's the part I'm looking at right now. And then I've got -3, -2, -1, 0, 1, 2. We got a lot of points that we can plot for this. 3. Okay, I'm kind of looking at this little snapshot on your table of values for your graphing calculator. And I'm looking at the y's that go with it. So when x is -4, y is -9. When x is -3, y is -2. And why don't we graph these as well? -4 is 1, 2, 3, 4, and down -9. We have -3, -2. And then when x is -2, we have +3 for y. So we go to -2, +1, 2, 3, put our dot. And this is what I mean by graphing precisely. Okay, I will be checking for these when you do your actual worksheet. You guys know the rules for graphing by now, so don't try to shortcut on this part. -1 and 6 go next, so -1 and 3, 4, 5, 6. Then we have 0 and 7. You can see that after 0 and 7, it goes back down to 1 and 6. Remember, we call that our vertex right there, our highest point. There was a maximum. And then 2 and 3. And these points should all be like, because it was a parabola, it should be symmetrical after our vertex. So we can kind of remember those rules of graphing parabolas. We haven't done them in a few months, but they haven't changed just because we haven't done them. And then we connect our points. All right, looks great. Okay, now if you look at your y2 column, and we do have our linear equation, we could just go off our rules of graphing linears. All right, we could do our y-intercept is 5 and it's a slope of 1/1 as we move up to the right. But we could also look at this table of values, and I'm going to use what I have here, like -4 and 1, and then it's 2, 3, 4, 5, 6, 7, 8, and so on. Okay, and we'll talk about some things you can also notice here on the table and on the graph that are similar. But let's go ahead and make sure you're just matching up. I'm looking at these two now, my red column and my x's. So when x is -4, then y is 1. So -4 and 1. Let's put a dot on there. And then we have, see, -3 and 2. And -2 and 3. And notice we're right on top of that other graph. That's important. Then -1 and 6, -1 and 4. Again, I'm looking at all these numbers in my red column. 0 and 5, 1 and 6. We're on top of that other parabola right now. And 2 and 7, and so on. Okay, so I graphed it precisely as we were instructed. Now, what are the solutions? That's what we got to answer right down here where I'm highlighting. The solutions. We crossed 2 times. We are crossing here and here. The solutions are written as ordered pairs where they are crossing. So I'm going to do that and show that in green right here. You can also see on the table, okay, the two y values are matching up. So the x value is -2, the y value is 3. So -2, 3 is a solution, and we're also crossing here. Okay, those match up at the coordinates 1 and 6. All right, cross 2 times. We can see it right here, like I said, where it's highlighted in green on the dots. They're crossing my linear equation and my parabola, my quadratic. They intersect twice, so 2 solutions. Okay, there's 2 solutions. All right, we're going to do number 2 as our next example. So clear out your old equations in your graphing calculator. And what you're looking at here on number 2, the first thing that you should notice is that both of these equations start with y equals. That means that they are ready to be graphed. And if you're looking at this closely, okay, let's look at the top equation. Y equals 2x squared minus 8x plus 3. We should be remembering that that makes a happy parabola. And then the next equation, y equals -2x minus 1 is linear. There's no exponent on our x, and it's got a negative slope. So we have a diagonal line that's moving downwards from left to right, and we're going to see if these two lines cross. across each other? And if so, how many times? So go ahead and get these typed into your graphing calculator, okay, on your y1 and your y2. All right, so your y1 and your y2. And then we're going to go to your, look at the picture, and you should see that you do have like a parabola that's opened up and a linear equation going downwards, and they are intersecting in that bottom corner. Next, go to your table of values. Okay, our x, we have a y1 and a y2. Now you can do these separately. You just can't see on the table of values how like the table numbers, like for the y's, they repeat, which is really nice. I like that they do that. And again, I'm starting with my parabola because that was given first. That's my y1, and it's in blue. And I'm looking for what can fit. Remember these graphs, okay? These are 10 by 10. So I'm kind of going and seeing how much I can fit on for my parabola. And I can't, like I have x, when x is -1, y is 13 for the y1, and that won't fit. So the first point I can really fit for my x and y's for the parabola is we have the point 0 and 3. So when x is 0, y is 1, 2, 3. Let's put that on. Then we can do 1 and -3, and 2 and -5. And we can do 3 and -3. Okay, so that meant we were at our vertex. We're going back up. And 4 and +3. And then we're back to 5 and 13. All right, so there's our quadratic, our parabola. And let's connect our points. We got our precise dots on there. I'm going up. All right, then I'm going over to my y2 column, and I'm going to basically kind of be in the same area. When x was 0, y was -1, so we have 0, -1. And then when x is 1, y is -3, and then you can see that those are the same, so we should be overlapping. Good. And then next it's 2 and -5, okay, and those numbers are matching up, so we can see how we're getting our solutions right away. And then we have 3 and -7 and 4 and -9. Or we are going down to right one. And we're going to connect our points. All right, so you'll notice you'll get quicker and quicker on this as you go along. We are intersecting 2 times. You can see those 2 intersections on the picture of the graph, and you can also see it on the table of values because our y values are repeating. All right, and that's what we're looking for all those connections. So then you go to your solutions down here, and we're going to write our solutions as x was 1 and y was -3. And our other solution was at 2 and -5. All right, next up on our examples is number 3. So looking at our equations, I see that I have y equals x squared plus 6x plus 4. All right, now this equation starts with y equals, so it is ready to be graphed. Now the second equation, it says x plus y equals -2. Well, x and y are on the same side. It does not start y equals, so we are not ready to put these into our graphing calculator yet. So remember, we need to solve for y. We need to get that y by itself. So we just need to subtract x over. And if there was a number in front of y, then we would divide, but we don't need to. We now have y is equal to, we always write our x term first in y equals mx plus b format. So y equals -x minus 2. And now this is going to be in like the correct order. So that is our y2 that's going into our graphing calculator. Okay, that's our y2. And this first one will be our y1. We're not looking at that x plus y equals -2. That is not something we can start in our graphing calculator. Our graphing calculator, to type it in, it does say y equals to begin. So you should have noticed that goes together. So get those 2 equations put into your graphing calculator. You will notice that you have a happy parabola. We had our quadratic for our y1, and then our linear equation ended up having a negative slope. So something like this is what we're looking at. After you get it typed in, let's go to our table of values. All right, and then I'll write down kind of what we should be looking at. Again, our tables, our graphs here go 10 by 10. So we're kind of looking to see what fits best on this graph. And I'm looking when x is -7 for the quadratic, y is 11. So that doesn't quite fit, but we can do that. So we have -7 and 11. So if I go 7 left, I'm 11 up. I'm just about right up there. I'm gonna go blue, because this is our blue line. If you didn't mess with your settings, this should be your blue line. And then next we would have -6 and 4. So going down. And then -5 and -1. And then -4, -4. -3, -5. Okay, and then that is our point of like symmetry. We are going back up. We have -2, -4, and hopefully you can see what's happening here. We have to be symmetrical, so I'm just working my way back up. And matching it up with our table of values, we had 0 and 4, and then 1 and 11 up here. And then we'll connect our points. Okay, then we go over to our red line, which is our linear part, our line. And we do have a lot of points. So let's just kind of match up with what we have here. Let's go red. So when x was -7, I had y was 5. So again, just make sure you're looking at the right columns. -7 and 1, 2, 3, 4, 5. No intersection right there. But then we had -6 and 4. Again, we should notice that those are matching up, and that means we should be doing a dot right on top of that other line. Then we have -5 and 3. Notice these are just going to go 3, 2, 1, 0, and then -1. Okay, it didn't get as far as there. Okay, so I'm just going to continue this down. Down 1, right 1. Oh, right on top. Connect the points. All right, so we graphed it precisely. We're looking for our solutions. We can see that they intersect here on the graph 2 times. We should be looking at our table of values. We can see where those 2 points are because the y values all match up. And then we're going to write our answers. Okay, we have 2 of them. When x is -6, the y value is 4. And for our next point, when x is -1, y is -1 as well. Okay, so that had 2 solutions. Okay, we're going to skip example 4 and go to example 5 next, and we'll just do 5, 7, and 9 here on the back so that you could be prepared to do your assignment. On number 5, the first thing I'm checking for is to see that they both start with y equals, and they do, which is great. So that means we're ready to type it into our graphing calculator. So you should be typing these into our y1 and our y2, clearing out any old equations so they don't mess up our solutions. Now, also another thing you should be noticing as you're going ahead, keep typing them in, is that on both of these equations, it says x is squared. So we have 2 different parabolas. So neither of these equations is linear, and that's okay, because we said at least one or more cannot be linear. So we have 2 parabolas, and again, these can intersect at most up to 2 different times. So get those typed in, get your graph, and you also notice one's a happy parabola and one's a sad parabola. So we've got our x, our y1, and our y2. And I'm looking at my y1 column. Okay, starting first, we'll do that in blue. And I can see that the first thing that fits on is when x is -4, okay, -4, that y is 7. So we're going to go 1, 2, 3, 4, and up 7. And then we can do -3 and 0. And then -2 and -5. And then -1, -8. And 0, -9. And then after 0, -9, it turns back up. We have 1, -8. So that was our point of symmetry right there, our vertex, and then it's just going to be symmetrical as it works its way back upwards. So that can help you kind of shortcut your graphing once you remember all those little steps and connect your points. All right, we're looking next at our second parabola, and that's going to be in our y2. Now, when I'm graphing this one, because I do want to be precise, I'm fitting in as much as I can here, you're going to notice when x is -6, y is -9, and that's our first point that fits on here. Okay, so we're going to do -6, 1, 2, 3, 4, 5, 6, -9. Okay, this parabola starting a little bit more to the left, and then we have -5 and -4. And then we have -4 and -1. And then -3 and 0. Again, we're seeing that those overlap. We're going to see it when we connect, and that was our vertex. And we're going to turn and go back down, -2, -1. So that was our vertex. It was a maximum, and we had our point of symmetry, so we are kind of working our way back downwards. Now, next we had -1, -4. So we're going to go down here, -1, -4, getting close. And then we have 0, -9. So you can see that they are right on top of each other, and those y values are matching up again. And then connecting our points. All right, and you can see, okay, next we got them graphed all up. We're looking at our points of intersection. Again, these are two solutions. Right there, they're crossing each other twice. We can see it on the table of values at -3 and for x, 0 for y, and 0 for x, -9 for y. And that's how we'll write out our solution. -3 and 0, and 0, -9. Two solutions. So we've had a lot of two solutions. We will see here some no solutions coming up, and on your homework there will be a time where there can just be one solution. It'll be pretty cool. All right, jumping over to number 7. All right, we've got two equations. We can see that they're both got x squared in here, but the big deal is they both start with y equals. Okay, so we have two different parabolas. They are ready to be typed into our graphing calculator because they start with y equals. Go ahead and type them in on your y1 and y2, again clearing out any old equations so it doesn't mess up your data. We have our y1 and our y2, and then hit graph. I'll just start writing out my table here as you do that. Okay, so you should notice that once you hit graph, you got a sad parabola and you've got a happy parabola that do not intersect. Okay, I know that, and so you can already tell that this, and you should understand, if they don't intersect, we do not have any solutions. I already know that this is no solution. Okay, you still have to graph. You don't get out of it just because it's no solution. Prove it, or you're losing points. Always comes up every year. Okay, so just so you know, you still have to graph it even though it's going to be no solution. So you're going to your table of values now, second graph. I'm looking at my y1, which is again in blue, and I'm looking what I can put on here. And we're going to have when x is -5, y is -6. So we're going to -5, -6, -4, -3. And then -3, -2. And then -2, -3. Okay, so we had our vertex there. We're going back down. And then -1, -6. And that's really all that fits nicely on our 10 by 10 graph. Connect our points. So notice I still graphed it precisely. And then I'm looking over at my second parabola, and I'm looking at what can fit on this one. And I really can't start fitting on this one until I get to when x is -1, y is 5. So we're at -1, but 1, 2, 3, 4, 5 up. And then 0 and 0. Yeah, nothing's matching up here, huh? 1 and -3. And then 2, -4. That was too much. And then after that, we were at 3, -3. So that was our vertex, and we can just start moving up symmetrically on our way back up. Connect your points. Okay, so I still graphed it precisely. Okay, there is no point of intersection, so there is no solution, but we still graphed it to prove it. Okay, our last example will be number 9. All right, guys, now this one will be a little bit different. We don't have any parabolas here. And this one right here, I'm highlighting it, x squared plus y squared equals 25 is not a parabola. Okay, this actually makes, oh, I don't like that. This makes a circle. Okay, when x is squared and y is squared, that makes a circle. And so 2 things for graphing a circle, okay, we need the center and we need the radius. The center comes from the numbers that are grouped with the x and the y. Because x and y, like they're both being squared and there's no parenthesis, that means our center is at 0, 0. Now, if we had any numbers in parentheses with x or y, they're both sneaky. They would both come out of the parentheses with opposite signs. But the center is at 0. We're always equal to the radius squared. So r squared is 25. So that means to find the radius, we would square root that. The radius is 5. So we just start this point by going to 0, 0 for our center. And remember, when we graph circles on paper, we need to do 4 points for a radius. We're going to go 5 points right, 5 points down, 5 points left, and 5 points up. And we're going to make a circle the best we can. Awesome. Okay, our next line right here, 3x minus 4y equals 0. This is linear. There are no exponents attached to our x or y. So linear equations need to start with y equals. So we need to subtract 3x over. So this is negative 4y equals negative 3x. And then we divide by the number in front of y. So we're dividing by negative 4. So we have y equals, our negatives cancel out here. We're equal to positive 3/4 x. And again, you can put that into your graphing calculator. You do not need to. Okay, notice the center is not an actual point here. So I erased it right there. 3/4 x, we have a y-intercept. This is like saying plus 0. So we start at the origin, and we have a slope of 3/4, so up 3, right 4. So 1, 2, 3, right 1, 2, 3, 4. Okay, now this is where me not being a super good drawer with my circle really probably should have been going through that point. Sorry. But you can see now, like, you might have to adjust. I could have edited my video to show that, but I kind of want you to see that for these circles, if it's really, really close, it probably is going through that point, because it's really hard to make an exact circle unless you're Mr. Goslin. All right, and then I go up 1, 2, 3, right 1, 2, 3, 4. But I can see I'm already past it, so I need to work to the left. I'm going back to the origin and going down 1, 2, 3, left 1, 2, 3, 4. Oh, I did better on that one. 1, 2, 3, 1, 2, 3, 4. And then we'll make our line. Okay, so we have 2 points of intersection here again. Okay, our line crosses our circles at 2 places. Okay, count it out if you need to, but those 2 places are at negative 4 and negative 3 on this left side right here. And then our other point is at positive 4, positive 3. All right, so you're going to see some different combinations on your assignment. Use your graphing calculator, use Desmos if you need to, but unless it's a circle, it needs to start with y equals. You're checking for that. If x is squared and y is squared, okay, like this, then they should be on the same side, and it's going to make a circle. Do your best, graph precisely, make sure you write down your solutions as ordered pairs. Good luck.